Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to fluid mechanics. In the previous video we discussed about surface tension. In this video we are going to discuss about another important thing related with surface tension, which is called as surface energy. So little bit of a recap. So surface tension is basically the phenomena because of which fluids at rest or liquids at rest, the top surface of the liquid, because of the cohesive force of attraction between the molecules at the top and the molecules within the liquid in a container, the top surface, it behaves like a stretched membrane and it's gradually little bit pulled downwards. Okay, it is pulled downwards and thereby causing a reduction in the surface area. So this phenomena of the downward pull of the liquid molecules at the top surface causing a reduction in surface area is called as surface tension. And we discussed the measurement of surface tension by considering the top surface of the liquid placed in a container, picking up 2 points A and B, joining them by a straight line AB of length L, the cohesive force between the liquid molecules acting on either side of the line AB, equal in magnitude, opposite in direction, given as F. Surface tension is the force acting per unit length of this line AB. So surface tension is expressed as force on either side of the length AB, that is F, divided by the length of the line AB, which is L, F by L. Its unit is Newton per meter, and this is all about surface tension. So you understand, surface tension is the phenomena of the downward pull of the liquid surface because of the cohesive force between the liquid molecules, causing an imbalance because the force due to air pressure is less as compared to the cohesive force because of the liquid molecules, which we have discussed in the previous video. So surface energy is basically the opposite of surface tension. It is the same thing, this concept is same, but when it is applied in the opposite direction, surface energy is opposite of surface tension. Surface tension tries to pull the surface, the top surface of the liquid, this downward, like this. It tries to pull it downwards, whereas this is surface tension. Surface energy tries to push it upwards, like this. This is surface energy, causing an increase in surface area. This causes a decrease in surface area. Surface tension causes that. Surface energy causes an increase in surface area. Okay, causing the liquid surface to move upwards. So surface energy basically is the work done on the top surface of the liquid, okay, to increase its surface area. Okay, work done against the force of surface tension. Okay, so let us try to understand what surface energy is. Okay, so basically if you try to understand it in a simple form, definition form, surface energy is the work done against the force of surface tension to increase the surface area of the liquid surface, the top surface. Okay, so it can be expressed as work done to increase the surface area and how much increase in surface area there is. Okay, so let's say initially the liquid, the top surface of the liquid was the surface area was AL. So work done to increase the surface area to in the opposite direction to the force of surface tension was done in the opposite direction. The work done was W delta AL. So surface energy is expressed as that work done in the opposite direction to surface tension divided by the increase in surface area of the liquid from, let's say it increase from AL to delta AL. So here this increase in surface area, the ratio between the work done opposite to surface tension divided by the increase in surface area, that is called as surface energy. It is expressed as sigma, this by this symbol. Okay, that is surface energy. So the work done against the force of surface tension per unit area in increasing the surface area of the liquid. Another important thing, which is at constant temperature, because surface tension is affected by temperature. We discussed that surface tension, it decreases with increase in temperature. So at constant temperature, work done opposite to the force of surface tension to increase the surface area of the liquid, that is called as surface energy, and it is expressed as work done divided by how much increase in surface area is achieved. Okay, so if we try to understand it, let's say we have a wire, okay, a wire, rectangular wire ABCD, where the portion BC is free to move either in this direction or this direction, towards left or right. This wire ABCD, BC movable, it is dipped in a soap solution. Okay, this is a soap solution which will have surface tension. Okay, it is dipped in this soap solution, as a result of which a thin film is formed on the wire. A thin film is formed on the wire. The thickness of the film you can ignore. This thickness you can ignore. Please, thickness is ignored for this discussion. Film is negligible. So we are concerned with the movement of this film. So here, because of the surface tension of the soap solution, this free end BC moves to the left. Okay, this free portion BC, it moves to the left. Okay, it moves to the left because of surface tension of the soap solution. So we know that surface tension is that force which causes the top surface of a liquid or any kind of a fluid solution placed in a container to be gradually pulled downwards, causing a reduction in the surface area. So here the soap solution, the surface tension of that soap solution, it pulls this portion BC towards the left, as a result of which this area of the portion A, B dash, C double dash and D, okay, A, B, C, D, that is, sorry, this is C dash, this is B double dash, this is C dash, okay, this is C double dash, that one is less, this area is less as compared to the area of A, B, C, D, okay, and as a result of the force of surface tension, this movable portion BC is pulled towards the left, causing a reduction in the surface area of the rectangular portion AB double dash C double dash D, which is less as compared to the area of the original rectangular wire ABCD. So here, to counter this, work has to be done in the opposite direction to move this portion BC towards this position which is C dash B dash, to increase its surface area. So when it is at this position B double dash C double dash, there is reduction in surface area, but when work is done in the opposite direction against the surface tension force to move the movable portion BC to a new position B dash C dash, here area is increasing. AB dash C dash D, that area is greater than the area of the original portion ABCD. So please pay attention here. Surface tension causes the movable portion BC, okay, this movable portion BC to move to this position B double dash C double dash, okay, B double dash C double dash, causing a reduction in the surface area. But surface energy is the opposite work done, opposite to the force of surface tension, which pushes the movable portion BC to the new position B dash C dash, which causes an increase in the surface area, okay, this as compared to the original area. So that is surface energy. So here, as the surface tension, it acts on both sides of the film. The length of the film BC is L, the length of the film BC is equal to L, and surface tension acts on both sides. Surface tension acts on both sides, top and bottom, okay, from the top and bottom, okay, like this. So that's why the total force acting on it is 2TL. So here the same thing, to move it to the new position B dash C dash, twice 2TL, this much amount of force has to be exerted. And here surface energy is given as work done to increase the surface area and the increase in surface area. So here work done is force into distance, so it is T into 2L into X. So this distance from the original BC to BC dash, that is equal to X. This distance is X. So here let us try to understand. This is the rectangular wire ABCD, which is dipped in a soap solution with surface tension equal to T. Let's say the surface tension is equal to T. Surface tension T is equal to F by L, force per unit length. So when this rectangular wire is dipped in the soap solution, it forms a thin film where the thickness of the film is negligible. So here the BC portion, that is movable, and we want this portion BC to move to this new position B dash C dash, okay, B dash C dash, opposite to the direction where the surface tension tries to pull it. The surface tension tries to pull it to the left, to this position. The surface tension, it tries to pull it to the left. This T, it tries to pull it to the left, to this position, okay, B double dash C double dash. But the surface energy sigma, it tries to push it away in the opposite direction to this position B dash C dash, okay, this position B dash C dash. So let's say surface energy, it pushes it away by a small distance x, okay. So force of surface tension that is given by surface tension is force per unit length. So force of surface tension is simply surface tension multiplied with length. But here, even if we have neglected the thickness of the film, surface tension acts on both the top and bottom surfaces. That's why here the total force acting will be twice of this. Okay, surface tension multiplied with length, twice of that, because it acts on both the top and bottom of the film. Even if the thickness of the film is neglected, for both top and bottom of the film. Now we know work done is equal to force into distance. Here, in order to push the movable portion away to B dash C dash, it has to be moved by a small distance x. This is the distance. So work done to increase the area is equal to force into distance, which is 2TL multiplied with x, which is equal to 2TLx. The initial surface area of the wire was simply the area ABCD. Okay, now the increase in surface area, this much portion is the increase in surface area. So it is simply L into x. Okay, BC, the length. Okay, this is the length of this movable portion here, the length of the movable portion, this one, this length BC, which is equal to L, and the portion, the distance which is moved. So this is the area, increase in area. But here, since top and bottom surfaces are considered, both top and bottom surfaces are considered, the total increase in area is equal to twice of that, 2Lx. Okay, this for both top and bottom surfaces. So work done is equal to 2TLx, work done in increasing the area, that is equal to 2TLx, and the increase in area is equal to 2Lx. So surface energy, as per the definition we know, surface energy is equal to work done to increase the surface area and the increase in surface area. So it is 2TLx divided by 2Lx. 2 cancelled, XX cancelled, LL cancelled. So here an interesting thing, surface energy is equal to surface tension. Very interesting. Surface energy is equal to surface tension. So what does it mean? Okay, it means that surface tension is numerically equal to surface energy. Okay, and the SI unit of surface energy and surface tension, that will be the same, Newton per meter or Joule per meter square. Work done divided by area, or simply force per unit length, they are the same units, and they are equal in magnitude, but the direction in which they are applied is opposite. That is the only important thing that you have to understand. Surface tension and surface energy, they have the same magnitude, they have the same units, but the direction in which they are applied, that is opposite. Surface tension tries to reduce the surface area by pulling or the downward surface, liquid surface, the top surface of the liquid downwards. Okay, surface energy tries to push it upwards, opposite to the direction of application of surface tension. It tries to reduce area, it tries to increase area. Okay, surface tension tries to reduce surface area, surface energy tries to increase surface area. they are in opposite directions. They act in opposite directions, but they have same magnitude, unit and dimension. Okay, so this is the important thing about surface energy, which we demonstrated with the help of this simple experiment of a wire with a movable portion BC of length L, which is dipped in a soap solution of surface tension T, as a result of which the movable portion initially it got pulled towards the portion B dash C dash, this portion, because of surface tension T. Then surface energy sigma had to be applied in the opposite direction to move it to this new position B dash C dash, and causing an increase in surface area B dash C dash C, this surface area, which is equal to 2 times of Lx, simply because both the top and bottom surfaces of the thin film were considered, and the total work done was equal to 2TLx, and the surface energy was equal to 2TLx by 2Lx, which is equal to T. Okay, so this is all about surface energy. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.